hardware. So we're going to talk about old hardware and VMware or the virtual machine and stuff. Now, I've been working on computers since a long time ago. And here is a wonderful book that it says, How to Be a Computer Operator. And it's dated 1986, I believe. No, 85. So look at the pictures and pass it around and take a look at it. This was actually decommissioned from a grade school library. And look at some of this stuff. You're going, oh my gosh, it's huge. So that's where we were. And I started in about 80, 81 when the IBM XT, or they call it the PC AT, started out. And it was only 2 floppies, IBM DOS. We had version 2.11, I think. It was quite entertaining in those days. We thought a machine was fast when you would do DIR and you could actually see the screen. It would go too fast that you couldn't read it. Because in the early days, you do DIR, you could read every line. Now it just screams by. So what I'll do is I'll start talking about the storage that happened about this time frame. Okay. Before we had ample hard drives, we used these things here called punch cards. And this is a Fortran coding sheet. And what you would do as a programmer, this is why whiteboard, write me a Perl for loop right now on that board. Doing Perl for loop? What? Yeah, that's how you used to have to write code. You would write it out first. Then somebody else would type it in so it goes on the punch card. And then if it didn't work, you had to go back to your sheet and figure out where your logic error was. So you had to do a lot of work in your head to make sure it was all right. This is why they have whiteboard tests, because if you can write code that's clean and it works off a whiteboard, you know your stuff. And I had a chance to work with some Cisco guys many years ago, and they were Perl, I would call them gods. They were very, very good at Perl. And they sat there and they just wrote this, they wrote 2 whiteboards full of Perl code. And we in the class were typing it in. They said, yeah, I haven't taught this class for a while, so this might not work. It worked. He got every comma, paren, quote in the right place. And Perl looks like line noise. It's hard to read. Okay, so storage was on these guys. And then what happens on the mainframe, as a computer operator, you would be in the computer room, which usually had a raised floor and was kept at like 72 degrees all year round, or 68. And this thing would go into what looked like a washing machine, and the whole drawer would pull out. This top part is not supposed to come off like this. What happened is, as the operator, you would take this and put it into the disk drive, pull this out, push it in very gently, and spin the drive up. This is where your payroll was. And then you have another disk for your general ledger, and another disk for accounts payable. So a computer operator would get all these things coming across the top of the mainframe saying, hey, you've got to change the disk drive. Go get this disk pack and put it in. That's what they would do. Well, now you are the computer operator. That job doesn't exist anymore because, everybody is their own computer operator. They manage their own disk and so on and so forth. So this was where it started. And then there was an upgrade. This had the same density as all of this. And it was a very, very sad day when a disk drive crashed. And what would happen is you'd usually hear it because the head literally flies across the aluminum substrate. And if dust gets in there, it would roll over and scratch like this. This is from a Fujitsu Csci drive. And you can see the rings in it. You're not supposed to see those rings. They actually ground through the magnetic substrate down to the aluminum. And well, that's shot. I'm not going to be able to recover anything off this one. So disk drive. Then the IBM XT, they had full-size hard drives. You know, full height. This is a 3.5 that fits in a full height. And you can see how this works. And what happens on this particular one is the head has been mangled off. But you can get the idea that it's pretty small. I think I have a couple more in here floating around. You can take a look at. These drives have been, yeah, this one has actually got you can actually look at the head and see what it looks like. But there was 5 1/4, then they went to smaller, and now they're down to what, 2.5. Now you don't even use spinners anymore. You use MMC drives, right? If you can afford it. But the MMC drives are screaming fast, work great. And let's see here, more disk drive stuff. Okay. This was state of the art. This is an 8-inch floppy. Now, some of you probably have never seen these. And then there's 5 1/4 inch, which you may have seen if you got some old PCs and old Apple laying around. And then we have, you know, the ones we're kind of mostly familiar with, 1.4 megabytes. And there were so many service calls. Hey, this isn't a floppy, it's a hard drive. No, inside is still a floppy, it's just had a hard case. So there was a lot of education going on to teach people the difference between the floppy, which are literally floppy, and these ones here. And then pen drives and so on and so forth. The optical, the mouse, this was from an Apple, and look at this mouse pad. It looks like a little shiny. Well, this has a grid on it. It's X and Y axis. And the way it worked on the high-end workstations at the time, Silicon Graphics, is it would actually count X and Y and translate it to your screen. Well, now what happens is in your mouse, and I'm sure all of you have played with the mouse, you take the little ball out and throw it around and torment your teacher with it. You ever figure out how they work? The way these things work is pretty cool. Is this mouse, very disintegrated, has 2 little wheels in here that look like saw blades. And what these saw blades do, let's see if I can show that in there. Not really. Is it goes between an optical sensor. Think of a flashlight and a mirror. And what happens is the light goes through and it counts clicks. Basically, it counts flashes. So when you move your mouse ball around, it moves these 2 wheels at different rates, but depending if you're going diagonally or in a circle, that's how you get your XY axis. And now they don't even really have the balls in there anymore. They're using just an optical sensor based off whatever works on the surface you're on. It doesn't work real well on mirrors. Has anybody tried that? Or glass. If it's glass and it's too reflective, it doesn't work very well. So a sheet of paper or something needs to go down so you can actually see in your mouse or use your mouse. But you can see how this works. There's a black and white sensor on either side of one of these saw wheels. And the black is I think the receiver, and the white is the sender. And it picks it up. And that's the mouse. And here's what happens when you put a floppy in your dashboard. And tape drives. Tape is still being sold. They have ridiculous quantities that you could put on the tape. They don't look like this. They're in a cartridge. IBM is kind of the master of that technology. And I can't remember, but it's just massively huge. And it's called Tier 4 storage, or, lowest. You can save everything off you can back up the entire internet and save it on tape. But it takes a little bit of time to restore it from tape, because tape is sequential. You put it on, you got to go all the way to the end and go all the way to the end. Okay. There's no random access read write like you have on a hard drive, where it can kind of bounce around and go find what it's looking for. And I'm sure you've all seen old episodes of Star Trek. And yep, this is basically VHS tape. And that's magnetic tape that you put ones and zeros on it. This is how you back up, in the days gone by, your machine. And when I was taking care of equipment, I always made sure I had backups. And then one of the things I did with the backups is that I would restore them. I make sure that the backups were good. I had another machine that I could actually restore everything from the backup to that machine. You would not believe how many service calls you end up getting. Oh, I backed up my machine, but now I can't restore. They put in a tape. And then they get prompted to put in the next tape. What do? They just put in the same tape. And they put in the same tape. So what did they do? They overwrote their own backup. Yeah, that's a very expensive mistake that's only made once, and you're updating your resume. It was kind of, and the poor guy was he ended up at Yuba County Welfare, and he was not an IT guy at all. He had no desire to be an IT guy, but they pushed him in that position. When all that happened, he found another job. I'm out of here. I don't blame him. But this is a floppy, how it works. Now, this is a very broken floppy. Now, what happens is when you put the floppy in, there's a lever that goes on here. And it pushes down. And these square thing up here, that's the actual head. That little square thing. And if you remember cassette tapes, it's the same type of technology as cassette tapes. It reads magnetic flux off of a magnetic substrate. That's all it does. So when you touch it, there's actual physical connection between the head and the floppy drive, which is why you needed floppy head cleaners, because they get gunked up. Okay, so this is a very sad floppy. All right, I'll get to those in a minute. Go through some more of these. And this is how we used to do print sharing. Hey, put it over on G. Hey, put it on H. And you look at those funny cables on the back. I think this is parallel print box, or it could be serial. I don't even remember. But that's how we used to do print sharing in the days before we had internet, before we had cable. BNC was a big thing where we did, 1 megabit, so much faster than modem. Now, what do you mean? I'm only getting 850 megabits. That's slow. Yeah, it gets spoiled in a hurry. And then I have some CPUs here. This is Sirica 1995. There's 3 million resistors on this guy. Million. And we're approaching billions in your PCs today. Well, especially your iPhone. Okay. This has 4.3 million transistors. It's an AMD K5. And in the box, there's this little black thing that looks like a pencil eraser with 3 pins on it. That's a single transistor. So you got 4.3 million transistors in this chip. Okay. And this one has, 3 million. So lots and lots of transistors. Now, right with that is this. This is a chunk of silicon that they make chips out of. Okay. This is it's the leftover piece after they finish slicing it. Okay. They take a bunch of little tiny slices and then they etch it, and then you get your chips. Because the individual chip inside the packaging is very tiny, very, very tiny. The packaging is large because you got to get all those pins connecting to your little tiny bit of silicon wafer. And I used to pass this around, but I don't anymore. This is, I believe, the 480, one of the early 486s. You see all those little squares? That's one chip. And I don't know if you've been reading, but Intel has now, this is put on silicon. Intel is now using glass to do this, which means cheap stuff is going to get cheaper, because now you don't get the density out of silicon, but you get, say, like you don't need anything that small. You can make a lot more chips a lot cheaper when you're using glass rather than silicon. And manufacturing is somewhat easier too. Right? And I'll go back to when I was working for this company, Tab Products. They had a whole division that was dedicated to field service, and they would work on what they called optical jukeboxes. And these optical jukeboxes is how they stored images, all kinds of images. And in those days, it was, we'll let the market decide. Everybody and their brother was getting into the market, and they made these 12-inch platters. Some were plastic. This is LMS. This is made out of glass. This is hard sectored. In other words, you might be able to see the little lines that go on that. It's also got a lot of fingerprints on it. But this was how they stored images. And I would take an LMS drive, and it'd be in the jukebox, and you'd have a bunch of platters in there, and the jukebox would move up and down, move this in and out, and it all worked great. But problem is, you had all your media in LMS, you couldn't take it over to Optimum and use it, or any one of the other 50 manufacturers. It was like the early days of the automobile. Everybody used different everything, and they even had different communication protocols. Then they slowly standardized on SCSI, and then they said, okay, we are going to make an agreement, everybody. Let's make an agreement. IBM and some of the big vendors got together and said, here's our worm drive now. Plastic, 5.25 inch. This holds 5.2 gigabytes. Write once, read many. That's it. You write once, never again. Once it's full, it's full. But in the early days of imaging, that's what the court said. You must have a perfectly reducible copy. Couldn't be a like copy. Well, the laws changed dramatically. And now you can have an image stored in JPEG, which is compressed, and that's considered legal evidence. In this day, it was not. So that's why everybody went to this stuff, because they had to, use it for medical insurance. All kinds of things were stored on these. I have no idea what's on this stuff. This may even be a blank one, who knows? But it would take forever to write, because you actually fire a laser to melt holes in the platter. So it took time. But you could read it, and you'd read it fine. But what the industry decided is that they agreed on a standard. The standard was the case. So you could put other drives in other drives, other media and other drives, and it wouldn't crash. But you still couldn't read it. So if you had an IBM and you wanted to put it to LS, you still couldn't read it. So there are all these different vendors who couldn't read each other's stuff. And there was a big business in converting, like the Library of Congress. Yeah, they got a bunch of the old stuff, and they move it from one media to another. And it's pretty crazy. So, but what put all this to rest? The CD-ROM. When they decided to make the CD-ROM an industry standard, everybody could make the drive, everybody could make the medium, and it was the race to the bottom line. And this market completely evaporated. So, you know, learn how to read financials so you can get out of Dodge before the ship sinks, you know. And yeah, no magic there. And if you know, if you don't, I guess this was how we used to connect to the internet. Acoustical coupler modem, 300 baht. You know, if you've ever heard my phone go off, see if I can find that ringtone. Well, if I can't find it, no big deal. Let's see here. Anyway, should probably go in another place. Sound. I'll do it this way. Let's go over here. Get through the ad. That squelching is negotiating at both ends. And then once it connects, you can now send your frequency up and down, ones and zeros, that will go over your modem. And you can find modem sounds from hundreds of years ago. And yeah, it was noisy and slow compared to what we have today. And that pretty much covers the old hardware. And to think, assembler, folks, is still assembler. Assembler still is assembler. You're still putting bits into registers on chips. So things mutate. But if you get a good understanding of how things are put together, like the theory of, you can usually figure out the problem. And here is the keyboard. Now, in the early days of keyboards, that did not happen. They all went. You got to play 102 key pickup. So that was a beautiful invention in my book. And this is a Csci keyboard. This is called the formatter board. And this is what takes the XY of your, this is silicon rubber that acts as the spring to push the keyboard back up. So when you push the keyboard down, it actually makes the contact smash so you can actually connect. If you spill Coke or soda on this, sometimes you can get your keyboard back by, cleaning it with distilled water, obviously unplugged, and put it in your dishwasher on the dry cycle, but not too hot. You don't want to melt it. Like, you don't want to do it like this. But you can get keyboards for $7 now, and it's dirt cheap. So I had a service call all the time on the old mechanical keyboards that were basically IBM selector printers, and they were springs under each key. And what ended up happening was this was in a burrito factory down in Chowchilla, and they said the right side of the keyboard, the left side of the keyboard didn't work. Okay. So I go down there and take a look at it. The machine was super dusty, so I cleaned out the dust, and then I split the keyboard very carefully so all the keys wouldn't fall out everywhere. And then on the left side of the keyboard, there was a dead roach, all smushed underneath the keys, all guts and everything. And well, he's been there a while. This keyboard must not have been working for a while. And so I cleaned it all up and it started working again. And I said, what was wrong? I said, you had a bug in it. So, but that burrito factory is no longer around. That's probably a good thing. If you had roaches in the keyboard. But you get stories like that when you work on computers. You get some very interesting stories. And I have some old poems that you've seen. You've probably seen those. Grandparents probably have some of those. And that's pretty much the old hardware story that we have for the stuff that it all comes forward. But disk drives still have heads that go back and forth. Tape still is sequential, and you have to go from one end to the other to find your data. So some of this stuff, yeah, it's gotten better, faster, smaller, better, faster, smaller, better, faster, smaller, better, faster, smaller. But the basic guts are still the same. The CD-ROM, when you burn a CD-ROM, it's very similar technology to the warm drive because you can burn it. You can do a rewrite on some CD-ROM media, but not rewrite too many times because it won't hold. So, any questions about ancient history? Aren't you glad you didn't live in those days? Yeah. It was a very different time. I won't call it better. It was definitely different. I will say that much. And so what we are going to do today is I gave you some homework to look up the register versus stack machines, garbage collection, self-hosting, what kind of tool chain. I gave you a bunch of different programming language to go investigate. What I'm going to do today is kind of walk you through one language to show you what you can kind of figure out with this stuff. So if you take notes, this is actually one language that I gave you, it's the Python. But what we'll be doing is we'll be using the Tux machine in front of it. So we're going to be doing several things on this machine. The login is Tux. Okay, so you are not on the shared machine. You're on the machine in front of you. That's Tux. And then the password Jeremy 231. And you'll log in. And then what I've got is a machine over here that is a virtual machine running KVM that's very similar to what you have in front of you. I may have some different versions of stuff, but for the most part, it's Ubuntu with all the updates and everything that you guys have had. There's a few things that are missing. Okay. And if you're in the Linux class, I think there's only one or two of you. We'll be doing the same thing. We're going to be building a virtual machine using KVM on Ubuntu on this box, okay, in front of you. Okay. So that's the old stuff demo. Okay. Let's talk a little bit about some specifics here. Now I need to go hit record for my screen so I can bring that up. Let's see, I want to bring that down. My Zoom meeting. Here we go. Zoom. Turn the meeting. Share screen one. All right. What we'll be doing is on the machine in front of you. Everybody logged in? Jeremy, all lowercase, all good. Okay. This user, when you open your prompt, I think this one works. Can you see that in the back or not? Okay. All right. You type in ID and hit enter. It will tell you what you are a part of. Okay. So notice it says SUDO. That means this is the administration user for this box. So this is also the password to destroy the box. Please don't do that. Okay. Or I'll make you fix it, which you probably don't want to do because it's a mess. Okay. It does need help. Okay. If you want to help me, volunteer and I'll put you to work, because what this machine does, it does some, these machines do some trippy things with that guest account. The guest account has been obsolesced. So I had to back into creating a guest account. When you log in with guest, it creates a temporary file space, mounts it, and then you read and write to your temporary file space. When you reboot, it goes away and it reinitializes. So it was jumping through a lot of hoops to make it work. So what we'll be doing today is we're going to start by creating a Python virtual environment. Okay. This is somewhat different than a virtual machine that is running Windows, something different than a virtual machine that runs Lua. Okay. What this does is it sets up a separate Python arena for you to add and remove software without trashing the Python that is on the system. Okay. It can be a big thing because most of your distributions are using Python somewhere in the management of that system. So to start with, let's type in Python minus uppercase V. And what do you see? Nothing, not working. Okay, let's do Python 2. Okay, that's not working either. Let's do Python 3. 310. What do you get? 310? You're all getting 310? So, okay, we're on the same version then. Good. So what we have is that I have the ability to download Python and compile from source and create a whole new version. Like on the Jeremy box that we shared system, you're on the latest version. It's Python 3.11. This is 3.10. 3.11 brought a lot of optimizations to the table for speed. But what I'm teaching you in this moment is something that's very pragmatic. It's very real world-ish. And you may never need this, but if you end up in a Python shop, or you end up doing data science, or you end up managing Jupyter notebooks for data scientists, you will be doing this. Okay. So it depends on where you go with your career. So what we want to do is create a virtual arena. Okay. So what we'll do is we'll just follow the steps. You just follow it like a cookbook. I'll be giving you the commands to start with. So let's do this. Which Python 3? And it tells me where Python 3 live. User bin. Sometimes you will find it in user local bin. Local is usually when somebody like me adds stuff to the system and it's not part of the original release. Okay. It's like on Windows, you get an extra drive, you put a D drive in, you put all your cool stuff on D drive. Okay. So what we want to do is, let me make sure I've got one. Okay, let me do that. Move VPY to VPYX. All right. What we will be doing is typing Python 3-M for module, and then VENV. In other words, we are going to create a virtual environment. Okay, another container, shall we say, like Docker container, for my special flavor of Python. Okay. And then we give it a directory name. And in this case, since I'm in my home directory, I'm going to create one called VPY. Okay. So I'm creating a virtual Python directory. Now you can say 3.10, you can put different versions on there and what have you. Okay. And you hit enter. And then you wait. Done. What just happened?
You said it was VEV?
Yeah. Victor, Echo, Nancy, Victor. Yeah, I'm gonna make that a little bigger. Is that better?
Yeah, that's good. Yeah.
Okay. And make sure you're in a home directory. So what did this do? Well, what this did is it ran a Python 3 program that used the module virtual environment and created a new directory and put a bunch of stuff in there. Did we get some errors?
Yes.
Ah, kind of errors.
Oh, yeah.
People who got here. So that's who else got these failing command? Pretty much everybody in the room. Oh, wonderful. All right. What do you think we should do? Pardon? I think we're running into sudo, but yeah, you don't need sudo for that. Yeah. So now it's telling you, say, apt install Python 3.10 VNV, but you need to type in sudo in front of it. So sudo space apt space install Python 3.10-VNV. It's like a calendar. And you put a password. You won't see any stars when you do password. So that's kind of annoying. Oh, you're a guest. You didn't log in as such. That's still never going to work for you. You type in exit. Type in, just hit Control. Yeah. Now, on your box, open a window. No, hold that down. You don't need to. Yep, now go up to the upper right. And say log out. Log out. Log out. Now change your user from guest to not. And log in. So if you log in as guest, it's not gonna work. Because guest is not as you do this. The password's up on the board. Now once logged in. Okay. So let's do type in that line up there. Okay, now you have to type in sudo. At involve Python 3. And then it will prompt the password. And then once it's working and the password's up there.
Yeah, it works now, yeah.
Yeah, and then go back and do that line and it will work. And what did it do for you? Well, I'll explain. If we change directory to VPY now, there's a bunch of new stuff in there. Dang, that's hard to see. Let's see if this one looks any better. That's a little better. But this all got created through that virtual environment. Okay. I'm not going to get into the deep guts of this stuff. I'm just going to show you what we are going to do with it. Okay. Now, once you change your directory to VPI or VPY, actually, you don't need to do that. Just do this. So if I do that, I'm in my directory. Type in the word source, and then you will say VPY/bin/activate. And watch what happens to your prompt. Your prompt changes to VPY. Now, if you type in Python -v, it's all there. Okay. So we now have set up a virtual arena for our Python. It's protected. So we won't trash the operating system version of Python. We can do whatever we want with this version, which is what we're going to do. Okay. And there is a command called pip. It stands for the Python package manager. And we just do pip and let's just hit enter and it will probably tell you something. You can say pip list and it tells you, oh, wow, look what I got. My version of Python only has pip and setup tools. That's it. That's all we got. So we want to add a few things to this. Well, I don't need to be rude. Yeah. I can build out my entire Python ecosystem with all the lovely hacker tools without needing root. Very handy. Okay. So what we're going to do is add a few things to this just so I can show you how this works. Let's say, hey, I want to see if I can upgrade. Okay. So let's just say pip install pip -- upgrade.
You're gonna want to use pip free.
Pardon?
No matter if you use pip or pip free.
If you're in the environment, it shouldn't.
Okay.
It shouldn't. The environment has all the right connections. When you type in source and you say activate, that brings up a nice new shell for you that creates a .local library in your home directory. So when you download stuff, it is in your user directory. This is not going to the system. Okay. So what should we install? Let's see here. Let's just do one. Let's do pip install mkdocs. This is what I use to make my website. Okay, hit enter. Wow, that's a lot of stuff. But that now allows me to run make docs and create a static website. I'm ready to do my own web hosting now. Boom, ready to rock and roll. So this is really quite easy. Anything's easy once you've done it 15 times, right? There is a tool that I personally use that has mixed results, but I will show it to you. Called pip-review. I use this for my Jupyter notebook stuff. Now, if I type in pip review, it goes through and checks all my version levels. If I want to update all my version levels, caveat emptor, this can be dragon. You can cause all kinds of headaches, especially if you're doing this on your system install without a virtual arena. You're going to be trashing all your libraries. You're going to wonder why your machine didn't work because you just beat it up. Okay. So if you say pip review minus AV, it will. Now everything's updated. I can do pip review one more time. And it says everything up to date. Yippee skippy, all security fixes. Now, where are these files going? Again, this is all going into our history file. Okay, so all putting this into our history file. Okay. Now, everybody have some fun to dig in a little deeper. Yeah. All right. We have a virtual arena now. We can do anything we want. We can do all sorts of fun things. And since you're on a Linux box, let's install idle. And we'll use idle in the GUI to write our code. So how do we install that? Well, we type in pip install, and I think it's idle lib. Nope. It's just idle. Isn't that cool? So now if I type in idle, I get this nice free GUI and say file new. Idle works the same on every distribution, Windows, Mac, whatever. Therefore, it works moderately well on everything. It is not perfect. It is quirky. Okay. So we are going to type in some code, and I'm going to save my brain a little bit. And this is very simple code. Where did I put it? Yep, that's it. Okay. So what we're going to do is we're going to type in some code. Now, what did I just show you how to do? We did, I'm going a little quick. We did pip review. We did pip install idle. Then I typed in idle. I got this screen that gave me the Python prompt, which should be familiar if you've had Python. If you haven't had Python, bear with me. Then you click on File New, and you get this blank, scary looking screen that looks like Notepad. That's basically what it is. Stripped down version of Notepad. And we're going to type in 4 whole lines. Okay. And we have a reason for typing in these 4 whole lines. Okay. I'll explain them all. This is all connected to our that stuff over there. And then I'm just going to call this hello 2.py. Don't you love the font? For X in range 10. Print. Done. All right, 5 lines. This is what we're going to use in our debugger and our disassembler. We're going to take a look at this code through the disassembler in Python, and then we're going to look at the kind of, well, okay, now let's relate that to the assembly language. We did it at the system level. Okay. So notice what I'm saying here. In the world of Linux and Mac, this shebang line tells the kernel, what do I need to run? In Windows, it uses what? The suffix of the name of the file. So if you click on an XLS, what's it do? It brings up Excel. If you click on a WPS or whatever it is, it brings up Word. Well, you do it this way in Linux and Mac, okay? You tell it what you want and you write your code accordingly. Then when you run this, it wakes up the kernel and says, hey, go search for Python in my working environment, which happens to be virtual. Go find Python and run this code. That's what it's saying. So now what I will do is say File, and I'll say Save As. And I want to put it into that PY directory, my VPY directory here. I call it hello2.py. I know that's a little hard to see, but I'm matching my file name. You can see it matches up here to here. And now, because I'm using the idle, it's right here. I've got that little R button up there. It says run. When I do run, I have an option. It says run module, i.e. my whole thing. I can hit F5 and it just runs. That's what it does. But it just prints hello world 10 times. Okay. Is it 1 to 10 or 0 to 9? Ancient history, Python. Okay. Well, let's cheat. What's X? My counter, right? So this will print my counter. F5, save it, yes. So what is it? 10 times? 1 to 10 or 0 to 9? 0 indexed. Just like pointers. Okay. All right. And now we're ready to do some tinkering here. Okay. So what is going on in our big scheme of things? We created a Python virtual arena that took a copy of the system 310 and made our own. This allows us to do our own thing without ruining the system. Python runs as a virtual machine. When you bring up Python, It's creating this virtual machine under the covers, and it runs the code that you type in to display that. It's acting like a pseudo. Where'd my transistor go? My chips. Who's got my CPU chips? In the back. Oh, you got all the stuff back here, huh? You probably got a bunch of it. Yeah. All right. So basically what we have with our Python virtual machine is a virtual CPU that has a virtual assembly language that has the ability to use a debugger in it. Okay. So let's play with some of this fun stuff. So to get out of this, you can type in exit, and it says, wait, use Control D or use exit. Your previous command is Alt P. Instead of up arrow, use Alt P. Why? You can change it, but Alt P will work on Windows, Mac, and Linux. Up arrow may or may not work on those. Okay, so you can do it this way. That works. Do you want to? Yes, kill it. Boom. So I've just closed my file. And if I change directory VPY here, here's my file that I just created. Okay. All right. Let's look at what the assembler code looks like in our Python virtual machine. Notice we're still in our active environment. If that goes away, we did an oops, and we need to reactivate it. Okay. Am I going too fast? I probably am. Let's look at history here. This is everything we've done so far. Plus a few other things. Not completely the same. Okay. So we did that. Okay. Now, to look at our code in assembler, we use another module. This. What am I looking at?
What was it that you typed in?
Oh.
I'm slow. Thank you.
Python-m dis, as in disassemble, and then hello py, and then displays the actual assembly language stuff that is running on the virtual machine CPU in software. So think of this idea of a virtual machine for Lua, Smalltalk, and keep going down the list, JavaScript, and so on and so forth. They created a soft CPU that runs registers or stack. In the case of WebAssembly, that is a stack-based machine, aka scheme, or register-based, which is Python and Perl, a couple of them. So this is actually the assembly language that we're using to run inside the Python virtual machine. Everybody understanding that concept? You know, because this is the kind of foundational stuff that helps you troubleshoot problems. Like, here's a true story. Today, or last night around 9 o'clock. I mean, instructors, well, it was around 7 o'clock. Instructors just went nuts. What happened to Canvas? Ah! I can't get in. Everybody's running around like, into the world. Well, yeah. The problem, folks, is we have a student management system, eLumen, and we have Canvas. They don't talk together very well at all. I have no idea what Canvas is written in. I have no idea what eLumen is written in. But this kind of problem is very difficult to solve unless you understand how those layers are built. Is this NPM? Is this, am I using Node and JavaScript? Or am I using PHP and with a database backend? Entirely different ecosystem and virtual environment and API connections. So I was, you know, everybody's trashing IT, and you guys have no idea what you're talking about. This is freaking hard. You know, why? Because let's get this piece of software. It's best of breed. This piece of software is best of breed. Oh, by the way, the state paid for that one, so we'll use that one. Oh, we got all these best of breeds, and we end up with a mutt. That's just the way it is. That complexity, you have to learn how to just, let's redesign it. Forget it. Just learn how to embrace the complexity. Because you're never going to get rid of it. You can clean it up a little bit, but some of the complexities there are way longer than you've been around. So keep your mouth shut, find out why the complexity is there. It may be pure ignorance. Well, then you can look like a god and make a big raise by using a one-line shell script. But you got to keep your mouth shut first, because you got to know how things work before you can get in there and change things. Okay. So this is what it looks like. Now I'm just giving you this kind of a demo of how this stuff works, how it connects. So we've created this bucket. We got our Python virtual machine. We just disassembled our hello world or our hello 2 into the appropriate stack. Okay. Now let's play with this one and type in Python debugger, PDB. And I want you to notice all the similarities that you already know from GDB. Go play. Blow something up. Change a register. Change a variable. Go. Next. There it is. Let's say X. Oh, it's 0. Let's say X equals 7. And then do next. And you can see these numbers counting. All the stuff you played with GDB, very similar to the Python debugger. Where do you think the ideas came from? GDB. There is a Perl debugger. There is a Lua debugger. There is a JavaScript debugger, although it's used inside of the browser inside your dev tools. Okay. Starting to see a trend here. All these languages that we build everything in or interpreted are sitting on top of these virtual machines that have their own assembly source that run on their own soft CPU. And then we try to get Canvas and eLumen to talk and it died. And we go, why? Where's your log files? Where did it die? If you can duplicate the error, you can fix it. If you can't duplicate it, it's virtually impossible to fix something that you can't put your fingers around because there's no box to put around. An intermittent problem can be very difficult. You can take years to solve some of those problems. Let's just hope it's not on a spaceship or an airplane or running your heart and lung machine. So you can see the level of software rigor based on what you're coding for. In the world that most of us will live in is the world of JavaScript and minimal viable product. Give me an 85% answer and we'll make it work, even if it doesn't. It won't talk to eLumen, but that's okay. We still get Canvas working. Okay, that's minimal viable product. It's different when you're doing something like a heart and lung machine. You've got a lot more vetting involved, a lot more test-driven development. Okay. Type in exit. And now I will exit one more time here. And I'm just going to close my terminal and open a new terminal and show you what we need to do to go back and restart everything. I've turned my machine off. I've turned it back on. I need to reactivate my Python virtual environment. And we do that by typing the word source. And then we give it the directory name, bin. And then this executable, activate, is actually part of what happens when you do your Python env. It actually puts that executable out there for you to activate. I am now ready to rock and roll in my own personal world of Python. So I can say pip list and see what I got. I got a lot of stuff. It gives me the tools. They all do something neat. Okay. Okay. So we did, let's do, was our creation. And let's do, let me change directory to VPY. Because there's my hello, it's still there. So I can run that. I can type in Python. And it runs. I can also make it executable. This is more of a Linux thing, Mac thing. chmod +X. Now all I have to do is type in hello and it runs. I still need the // because I don't have VPY in my search path. Linux questions for that. Okay. Now let's look at that debugger again. So I can type in Python. So I can do all kinds of fun things. Yep, this isn't in there. I can't do this because I haven't imported it. Okay. I do want to show you that, but okay. If I just say there's, I type in L, gives me that look familiar. Yeah, so you could just see this familiarity. This is very common in a lot of these languages, especially like, Perl and Lua, a lot of them. Why reinvent the wheel when GDB works? You just adapt it to your language and then off you go. Okay. All right, so we're good. All right, so you can play with this further, but I do want to show you Let me see if I've got this. Yeah. Nuts. All right. Oh, never mind. This is not going to work. Never mind. We'll do it with so if you just type in Python and hit enter. We use two modules. One of them is called dis. Well, three really. We use dis for disassemble. We use Python debugger, PDB, and we use DND, right? Let's type in import. Now this is pretty Python specific, but there's two little commands I want to show you. If I say import, and let's use dis. I've just brought in that module, the disassemble module, into my working arena. But how do I look at it? Anybody know? That's the one thing I don't like about using ZY books. I can't teach this kind of thing. It doesn't, it's not even part of the book. Well, once you import something, you can do dir on that something, and it shows you all the methods or objects or functions that you can access. And if you want to look at something specific, how about code info? I can type in help dis.code _ info. Now, this is the kind of stuff that is obscure and nobody tells you. You got to go dig in the manual for 40 days to find this. You get it for free. And it shows you help on function info. And it shows you that's what it is. That's it. That's it. So you can type in help on the entire assembly, on all of it, and it just goes on for days of all the stuff you can do. But this is a slightly better formatted. Okay. So what did we actually type in? I have, my screen has all been wrong, but that's okay. The screen, I'm doing a screen share anyway. So what have we really been doing today? We use Python -m for module, ENV, but we had to install that, right? Because we had an error, and then we give it some dir name. Okay. Then we did the module for the debugger, or old debug, and then we did the module for the disassembler, and we wrote some code, really short code, and then we did import some module name, and then we used dir module name, and then we did help module name. And that's all we did. Your brain's full. And we talked about ancient hardware. Now, you do not have to go into this detail for each one of these programming languages. What I want you to do is go explore those languages and find out if they're using stack-based or register-based. You may have to dig a little deeper than just Google to find it. You usually can find it if you try to find out who wrote the language, like Lua, the fellow is out of Brazil. If you look at some of his documentation, he'll have that information in there because he designed it from the ground up. And Lua is It's a really cool language for small, fast systems when you need optimization in the small. Very slick. Python's great for data science because you can just bring in anything. You can bring in the geotags, you can bring in all kinds of stuff. Yeah. You could do a profitability by head count with Python. Which one of my workers is making me the most money? They get a raise. Okay. So you can see what we've got here. Okay. And then that. And then I showed you how to create the virtual environment. Okay. Cool. Now you've got a few minutes left. Keep this fresh. Write down what you just did. Because the Python virtual arena is exactly how you are running the Jupyter notebook. When you log into the Jupyter, you get a Jupyter notebook virtual environment. That's version 3.11, not 3.10 or 3.8 or whatever. So if you're interested in learning how to get this more current and how to update it something later, I can show you how to do that too. This is the weird kind of stuff that I don't know where you find it. It's, you get stuck in. Okay. All right. Now you have some time. Go look up Lua. Or if I were you, I would keep this fresh because this one, just unless you know you're going to go to work for a gaming company that uses Lua, Python is a meal ticket for data science, chemistry, physics, biology, you name it. It's everywhere. The GIS, geographic information systems, Python is a big player. Esri uses a lot of Python. So, all right. Now go home and do this on your own virtual machine. Spin up an Ubuntu and walk through the steps. And if you want to hang around for the Linux class, we'll be experimenting with these machines running virtual manager, and we'll be creating virtual machines using the KVM tool chain. So it's a different tool chain than VirtualBox or VMware. Way faster. Not as pretty, but it is faster. Anybody change their X in the debugger? Yeah, and you got it to go through the loop faster. Yeah, just like GDB, huh? And then if you want to deactivate this without exiting, see, I'm still in my arena. You just type in deactivate. There we go. And it deactivates. I have to show you this one. This is kind of fun. This is using a simulation using the Python turtle module. The turtle module is a turtle program, but it has all these demos built in. So what's cool about Python is you can have a running piece of code. You turn around and use that as a library for your next project. You can do the same thing in C++. It's just a little more convoluted, okay? So what I just did is import turtle. So I use my two commands here. There's all the things I can do with turtle. And then if I would do that with help, as it generates everything. I mean, that's too big. Sorry, I won't let you do that. So let's do if you let's just take my turtle home. Okay. Now I'll show you some code. I don't know if I have it on this machine or not. I might. VPX. Oh, I know what I can do. We'll do that one. Oops. Run my alias so I can run that. You can do GUIs with turtle. Really simple. And in ZY books, we don't get into this. But what does that actually look like? You import and then you just print it. So it's really easy to do GUIs inside the turtle with Python. So if you want to write a game, nothing's stopping you. You got all the tools you need. Go for it. Look at the turtle demos. And PY game is another one. Okay. All right. A lot you can do. I've got the days alive in here. If I did that in Python or Bash. Yes, yes, yeah. Good. Days alive. Oh. Okay. I haven't looked at this code in decades, so there's some pieces that are missing. Okay, that's all I have. If you're in the Linux class, feel free to hang around.
But you can print out tomorrow.
Ah, yes, piece parts.
Yeah.
Days gone by, huh?
Yes. Oh, would you like to see that?
Oh.
Right,
Ambassador.
it's kind of weird.
Do you know how to run the dis module from within PDB? I can import it, but
Oh,
it doesn't seem to do much.
you can, there's a couple different ways you can stack it. I was using it just in a very simple for today. But yes, you can actually embed both disk and the debugger into your code.
Sure.
So, and then have it trigger from inside your code.
I'm just in the PDB interactive terminal, and I wanted to disassemble the file from within there.
I think if you bring in the disassemble before you bring in the debugger. So if you would type like import disk, import db, or your Python,
Oh, okay.
it should work. Let me see if yeah, I didn't look into that. Let's see here.
Good day.
You too. Trying to remember how to load, I can't remember. Well, I guess I better turn off.
Loaded file.
How you doing?
Me, I'm good.
You ready to have some fun?
Until my brain stops accepting information.
Yes, tonight we're gonna be building some virtual machines on the boxes in the room.
Oh, cool.
We'll be using KVM.
You can just type Python-i and that's the file name.
Oh,
Yeah.
I,
Yeah, if you exit the terminal there, delete it.
whoops.